I forgot to mention in the previous session that I took a bit of a break, a few days, not filmed, not written anything up on the board, but I did go to my website and I looked at videos on YouTube, my clips, and if there was some kind of heading in each session, then I would write that heading as a kind of comment on the right hand side of the link on the website. So now within a lecture, within a chapter, you have now many topic headings, if you like, on the right hand side. So you no longer get like a long list of just links and that's all, because then you don't really get much of an idea of what's going on, what the content is of all these clips. I mean, there may be dozens of these links, of these clips, without any reference to what they're about, to the content. So now in blue, so these topic headings are in blue on the right hand side of, not all, maybe one in, I don't know, 4 roughly, clips has a topic heading. So you get a more detailed idea of what's going on in each clip within the chapter, within the lecture, because just one lecture, one chapter, and some lectures have many parts, several dozen. So that I hope will help focus on what the content is of these clips. So I spent my time doing. Now I'll do that systematically for all my courses. I've been putting it off for a while because someone suggested that I do this. They said it would be a lot more helpful, and I agreed. But I've been putting it off because I was under the impression it would be a hell of a lot of work. And so I finally bit the bullet, and 2 days ago I started doing it for the first dozen or so clips, and I was pleasantly surprised. It was a lot less work than I'd imagined, because for a start it was only about 1 in 3, 1 in 4, something like that. Clips had any labels, topic headings, because quite often I do several sessions on the same topic heading, and so quite a few of them I just didn't put any comment, nothing on the right hand side in blue, and so it went rather quickly. And I'd look at the first session of a board, I'd look at the first part, because a session can consist of several parts usually. Part 1, 2, sometimes 3, 4, occasionally 5 parts per session. So I'd look at the first part of each session to see if there was a heading, and if so, put it as a comment on the right hand side after the link. And it went a lot faster than I'd imagined, so great. So I've done most of this course so far. Now it has blue topic headings on the right hand side. And I'll do the same for the previous 2 courses. First course was on finite group theory, junior senior level, and second course was on senior level quantum mechanics. So I'll do the same. So I hope you find that useful. You can go fishing within a lecture, a chapter. Now, if you want a particular topic, you'll probably find it. So, for example, your first just formal description of a Turing machine, something like that, you'll be able to find it and then actually look at that particular clips. Right? Okay, so getting back to, we're talking about modifying a language. We're talking about D1, where that was the set of all polynomials of a single variable, x, that had integral roots. Root was just a solution to the polynomial equation. The right hand side was 0. Right. So, and we created in the previous session, we created a Turing machine, M1, that could recognize that language, D1. Yeah, D1. And and then we described an algorithm that would recognize that. Now, we're sort of merging, almost, they're becoming sort of synonymous now, an algorithm and a Turing machine, because an algorithm is just a Turing algorithm, okay? And so we're going to increasingly now, especially this in this session, we will increasingly decrease emphasis on the machine side, the Turing machine, and we will increase emphasis on the notion of the algorithm. So we'll focus more, if you like, more on the algorithm and less on the machine, the Turing machine, how it's implemented or whatever. Okay. Now we can, given what we did with D1, that was a single variable set of polynomials that have integral solutions. Let's go back to D. That was the more general case where you'd have multi-variable. You had more than one variable in your polynomial. Now we could find an algorithm machine, Turing machine. So thinking the two are the same, effectively the same nowadays, from now on. So we can create a Turing machine, or an algorithm, called M, where, so similarly to what we did with M1, we just systematically go through all possible cases of integer values. So imagine, say, your polynomial has three, saying earlier, has three variables, x, y, and z. Then you just give x, y, and z all possible integer values. So your x can range through all the integers, your y can range through all the integers, and your z can range through all the integers systematically. And you just cover all combinations of those three integers for x, y, and z, right? So that you cover all possible candidates as roots, and then you test them. For each one, you test whether the polynomial equation comes to 0. If you plug in those values, the integer value for x, the integer value for y, the integer value for z, into your polynomial equation, do you get 0 on the right hand side? And if you do, then that machine M, big M, accepts. Okay. So in other words, M1 and now this new machine M algorithm, they both accept. So these two machines, M and M1, are recognizers. Okay, so if the polynomial does have an integral root, then this machine M will find it by systematically going through all possible combinations of integer candidates for x, y, and z. So if there is a solution, if there is a root, it will be found eventually. Right? The machine will find it. So it is a recognizer, but it's not necessarily a decider. We talked about the difference between those two. So a deciding machine never loops. Right? So that's the essence of a decider. It never loops. It's always for each string it either accepts or rejects. Whereas a decider does perhaps loop if it gets a string that is not if its string is of a polynomial that is not an integral solution.